Hello students, this is Dr. Jayshree. I am Associate Professor in Department of Electronics and Communication Engineering, B.V. Raju Institute of Technology. Here we are going to discuss today about the course Linear and Digital IC Applications. In this, the topic we are going to see today, which is Combinational Logic Design using MSI circuits. So, combinational logic design using MSI circuits. Till now, we have seen the combinational circuits which are designed using the traditional methods. Traditional method, where the combinational circuits are designed using logic gates. And we discussed about the simplification of combinational circuit using different logic gates. But number of logic gates, if it is increased, the complexity of the circuit is increased, and hence we are using the integrated circuits that are MSI, medium scale integration. Integrated circuits are easily available and can be used for simplification of combinational circuits. So let us discuss today about the design of combinational circuits using integrated circuits. So there are different type of combinational circuits are used in digital design, such as multiplexers, demultiplexers, decoders, code converters, encoders, adders, etc. All these are the combinational circuits which are used in digital design. So these combinational circuits are familiar with all the functions which are to be performed, and they are available, but limitations of the device is to make an effective and optimum set of such devices. So let us see the first one, which is the multiplexer. A combinational circuit, one of the important circuit is multiplexers. Multiplexers are also called as data converters. Multiplexers are also called as data selectors. Data selectors. So this is one of the special combinational circuit which is most widely used. The multiplexer or data selector is a logic circuit which is select one out of multiple inputs and generates the output. Right? So multiplexer is also called as data selectors, which will select one of the data from the many inputs and given to the single output. These data selectors we can explain from the block diagram. Just we'll see the block diagram of this general multiplexer, in short called as MUX. So there are multiple data, multiple input data which is written name as something I1, I2, I3 and so on IN, and it transfer the output to the single line. That output is given as named as Y. So among these many inputs, a single data is chosen, and that depends upon the inputs called as select input lines. Let us name it as S0, S1 and so on SM. So this is the data input and this is your select input lines. So for selecting one input from the n inputs, we need m number of select input lines, and the relation is 2 power m equals to n, where m are select input lines. So we require m number of select input lines to select one of the input. So m is nothing but your select input line or select input, and n is nothing but your input data. For example, suppose I have 4 inputs, then how many number of 4 inputs, then how many number of select input lines are needed? So you have n value is equals to 4, then 2 power 2 is equals to 4. It means that m equals to 2. So you need 2 select input lines for design of this 4 input to 1 output multiplexer, right? So if you have to show the block diagram for 4 into 1 MUX, in short it is also called as 4 into 1 MUX, where I have 4 select inputs, 4 inputs. That 4 inputs are I0, I1, I2 and I3, and you need 2 select input lines S0, S1, and output is taken at Y. So this is the general diagram for 4 into 1 MUX. So how will you write the equation for this? So to write that equation, I have select input lines as S0, S1 and your output is Y. So what is selected? If my inputs, select inputs are 0, 0, then it will select I0. If select input is 0, 1, it select I1. If select input is 1, 0, it select the data input as I2, and when S0, S1 are 1, 1, it select I3. This is the table, truth table for this 4 into 1 MUX. And from this you can write the equation Y equals to, I need S0, S1 as 0, 0. So that is S0 bar, S1 bar, I0 plus S0, S1 bar, I1 plus S0 bar, S1 I2 plus S0 S1 I3. This is the output equation for this 4 into 1 multiplexer, and from this we have seen that how to draw the logical diagram by using the logic gates such as AND gate and OR gate. But now we are going to see today the design of this combinational circuit, that is we are seeing multiplexer MUX using ICs, integrated circuits, right? So let us go with this. Since multiplexer is a function which is we discussed just now, and this is used as a logic circuit which will select one input from the multiple output. So these MUX or multiplexer circuits are available as integrated circuit as 2 into 1 MUX, 4 into 1 MUX or 4:1, then 8:1 MUX, 16:1 MUX, and so on. These are the different set of multiplexers which are available in the form of integrated circuits, right? So what are these different multiplexer ICs are available? Let us see. So different ICs which are available are IC 74 series, and 74150 is 16 into 1 or 16:1 multiplexer. 74150 is 16:1 multiplexer IC which is available. Then 74151 is 8 into 1 or 8:1 multiplexer which is available. You have 74152, again 8:1 MUX. You have 74352 is dual, 4 into 1 MUX. 74153 is again dual, 4 into 1 MUX. 74157 is quad, 2 into 1 MUX, and 74158 is again quad, 2 into 1 MUX. These are the standard MUX ICs which are available for design of these multiplexer circuits. So what is the difference of this quad 2 into 1 MUX? Again 74158 is also quad 2 into 1 MUX. This is same as input. So whatever the input data you have applied, the output will taken as same as the input. But in 74158 it is inverted input. So 74150 is 16 into 1 MUX, again inverted input. 74151 is complementary outputs, right? 74152 is 8:1 multiplexer which is again inverted input, right? So what is meant by these are the different specifications for this ICs. Now you have the question like what is meant by dual, what is meant by quad. So 74151 is 16:1 MUX which have single IC. which have a single IC with single multiplexer. Whereas 74151 also a IC which have single 8x1 mux. But if you look at 74352, this is dual 4x1 mux. In one IC, there are two multiplexers present. And in this 74153, again 2 mux are present. That single IC consists of 2 mux. This single IC consists of 2 mux. Right? And cord means 4 mux are available in a single IC package. 74157 and 74158. Right? So this is what the different mux ICs which are available. Now, what are the advantages of these multiplexers? First, simplification of expression is not required. Let me erase this one. Simplification is not required. Second, it minimizes IC packages. And third one, logic design is simplified. These are the advantages of this use of integrated circuits. Right? Now, you are designing the mux. The logic element, multiplexer is the logic element where truth table is one of the standard form of logic expressions to be available. Right? Now, what is the design procedure? Design procedure. First step is identify the decimal number. Decimal number corresponding to the min term. Identify the decimal number corresponding to the min terms in a expression. Right? And the input lines corresponding to these min terms are connected to logic 1. First, so identify the decimal numbers in the given expression and the min term expression corresponding to the min terms and connect all that min terms to the logic 1. First step. And all the other input lines are connected to the logic 0. Right? And third, inputs is applied to the select input line. That is the design procedure. Hope you understand this one. Let us go with the design of one example. Example, implement the expression using a multiplexer. The expression is given as function ABCD equals to summation of M min terms 0, 2, 3, 6, 8, 9, 12, 14. Implement this expression using multiplexer. Right? So you have in this given design problem, you have 4 variables, that is A, B, C and D. These are the 4 variables. Therefore, this multiplexer require 4 select input lines. this multiplexer require 4 select input lines, right? And if you see in the given expression, the mean term is start from 0, decimal value 0, and the highest mean term with decimal value is 14. So you have to identify which multiplexer you have to design. And hence here this multiplexer is 16 into 1 mux, where you need a 4 select input lines, right? So how will you design this? The first step is whatever the mean terms are given in the given expression, given problem, write the decimal value of that given mean terms. So these mean terms are given with the decimal number only. So you have to use a multiplexer which is 16 into 1 multiplexer. So you have 16 data inputs. We will define as something 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. These are the 16 input lines and a single output Y. And as per the requirement, as you have the 16 inputs, so the 2 power m equals to n. So n is equals to 16. That's why you need 2 power 4. So 2 power 4 equals to this 16. That's why number of select input lines are 4, and that are mentioned as A, B, C and D, right? These are the select input lines or select input. This is your data input. So first step is identify the decimal numbers corresponding to the mean term. So this mean term is given here as 0, 2, 3, 6, 8, 9, 12 and 14. Connect this to the logic 1. So you have 0, then 2, 3, 6, 8, 9, 12 and 14. These are connected to the logic 1. And the rest of the inputs like 1, 4, 5, 6, 7, 10, 11, 13, 14 and 15 and 16 is connected to logic 0. And at the output you will get your function. Simple. This is the design of multiplexer. Right? Now we'll see one example of, if you are seeing, this is the example of 16 into 1 multiplexer for realization of this function. This IC 74150 is 16 into 1 multiplexer IC, right? So pin diagram, if you see pin diagram, or you can call pin configuration of this IC, then it is a 24 pin. So what are the 24 pin consist of? 16 are your data inputs, right? So let us define pin number 1, 2, 3, 4, 5, 6, 7, 8, right? 9, 10, 11, 12 are the pin numbers. 13, 14. So this is the 14 pin IC. This IC is 74150 mux, which is 16 into 1 mux. So here pin number 1 to 8 are data inputs. D0, D1, D2, 3, D4, D5, D6 and D7. These are the data inputs. Also you have 11, 12 also data inputs. D8, D9, D10, D11, D12, D13, D14 and D15. These are the data inputs. And pin number 9 is a strobe, which is extra control signal called as strobe or enable signal. Pin number 10 is positive supply voltage V plus, right? And pin number 11 is A minus, and this is ground. Pin number 12 is ground. So these are the data inputs: D9, 10, 11, 12, 13, 14, 15 and 16. These are the data input lines which are chosen here, right? And pin number 10 is output, 9 and 12 is nothing but your strobe and enable and ground signal. 24 is your output, right? So pin number 10 is output, right? So that's why if you have implement this function using the IC 74150, it have the output as logic low, like 0, and these are the data input lines. This is one of the IC which is 74150 used for design of multiplexer, right? So similarly you have to design the multiplexer circuit using the different combinations of ICs such as 74151, 74152, 74153, 157 and 158. These ICs are used. So we have seen today combinational logic circuit, which is multiplexer design using integrated circuit. So let us stop here and we'll see the design of demultiplexer using the integrated circuit in our next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.